All right, hi guys. So for exam 3, I wanted to quickly go over prokaryotic regulation, more specifically about the negative inducible regulation portion of the Lac Operon. Okay, so a quick overview of the Lac Operon. So we have our promoter region, our operator region. We have our 3 structural genes, LAC-Z, LAC-Y, LAC-A. LAC-Z creates beta-galactosidase, LAC-Y creates permease, and LAC-A creates beta-galactoside transacetylase. And we also have our LAC-I gene, which creates the Lac repressor. And as mentioned before, this is an example of negative inducible regulation because it's negative because we have a repressor which inhibits transcription, and it is inducible because it is an operon that can be turned on. Also, the expression is induced by the presence of lactose. Okay. And so in the absence of lactose, the repressor would bind to the operator and shut off transcription. And then in the presence of lactose, the repressor would bind to lactose, and it would prevent it from binding to the DNA. And so then we would still get low rates of transcription. Okay, and so we have our Lac operator O site, which is the binding site. We have the Lac repressor I, we have the structural gene Z, and we have mutations of the Lac operon. So the OC operator mutation is where the operator is mutated so that the repressor molecule can't ever bind. The LAC-I repressor mutation is where we get an inactive Lac repressor, and the LAC-IS mutant is a super repressor, and so this means that the repressor can't ever be inactivated, and so that the repressor will always bind to the operator and block transcription. And it is important to note that O acts in cis to Z, I acts in trans to Z, and OC is epistatic to IS, which I will explain further in one of our future examples. Okay, so here is another diagram of our Lac operon, and in this case, I wanted to go over whether or not you would get expression of our structural genes based on 4 of these conditions. So if we did not have lactose, we would have our repressor binding to the operator, which would block the expression of our genes. If we did have lactose, the lactose would bind with the repressor, and the repressor would not be binding to the operator, and so we would get expression of our structural genes. If we had our LAC-I mutant, we would be creating a mutated form of repressor or inactive form of repressor, and so then in both the presence or absence of lactose, we would get expression of our structural gene. And if we had our LAC-OC mutant, this means that the operator is mutated so that the repressor can't ever bind to it. So in both the presence or absence of lactose, we would get expression of our structural genes.
All right, so we'll be doing some partial diploid practice problems. And so here we have, with partial diploids, we have 2 sets of genes. And then here we're just determining what the LAC-Z enzyme activity would be. We would say whether or not it's functional. If it's functional, it has normal amount of enzyme. If it's non-functional, we get transcription, but the enzyme that is created is mutated. And if we get no transcription, the structural gene is not transcribed at all. And we'll determine this based on the presence and absence of lactose. So the first step I like to do is to look at the parts of the genes in our set that are non-functional. And so here the LAC-I mutation does not work, and then the LAC-Z gene here also does not work. And since LAC-Z works in cis to O, I would cross out both of these genes altogether, and because I works in trans to Z, I can just focus on this set for my genes in order to solve the problems. So I will do this for the remaining sets of problems. So the I doesn't work, this gets crossed out together. I'd be focusing on this, and then number 3, Okay. And then, all right. Okay. Well, this I'll first leave for now. Okay, and so here in this case we have a super repressor, so that means that no matter what, we will not get transcription of LAC-Z. So whether despite presence or absence of lactose, we would get no transcription for both. Okay, and then for number 2, we get our normal conditions where we have normal I, O, and Z. And so in this case, when lactose is present, we get functional and enzyme, and then when lactose is absent, we get no transcription. Okay, and then for number 3, we have the super repressor, and we also have the operator mutant. And then as mentioned before, the operator mutant is epistatic to the super repressor, which means that this would have priority over the effects of the super repressor. So no matter what, we would get functional enzyme for both presence and absence of lactose. This is not functional, this is functional, and both of our LAC-Z genes are non-functional. So in the end, we would get non-functional LAC-Z enzyme created in the presence and absence of lactose.